session is by Professor Siddharth Tallur. Siddharth Tallur is BTech in Electrical Engineering from IIT Bombay and MS PhD in Electrical and Computer Science from Cornell University. He's Associate Professor in Department of Electrical Engineering at IIT Bombay. Previously, he worked at Analog Devices in Wilmington in USA from 2013 to 16 as MEMS Products and Applications Engineer. His research interests include high resolution and low cost physical and biosensors and high speed instrumentation and embedded smart systems for sensing applications. He's currently serving as a faculty in charge at Vadhwani Electronics Lab at IIT Bombay. So he has been experimenting with laboratories and he will be sharing his experiences with us today. With this brief introduction, I'll hand over to Siddharth.
Yes, thanks, Professor Patwardhan. Am I audible?
Yeah, you are audible. Yes.
Okay. All right, thank you. Yeah, so what I am going to share is work that we have been doing at Vadhwani Lab. And we also ran a few lab courses last semester. So you may see kind of some overlap in the model that Pradeep described and that I'm going to talk about. But the challenges that we have as electrical engineering department for operating electrical engineering labs are a bit different. So I'll start out again. I have this very extempore kind of presentation. I don't have a very just one slide deck. So I'll also share my screen in a little bit and show a bunch of things like Pradeep did. And mainly, I just want to talk about how this motivation had come up and where it had started, how it had evolved, because we were doing things with kits long before the pandemic. So in the Vadhwani lab, this I think has been going on since 2011 or something like that. So why this had started and how this helped us with the online labs and what we can do ahead, right after, maybe after this pandemic also. So those kind of things maybe I'll talk about. So let me see if I can share my screen. All right, I hope my screen is visible. Okay, can somebody please confirm?
Yeah, your screen is visible.
Yes. Yeah. Okay, thank you. Yeah. So before I start, I'll just start with acknowledgements. This idea for doing this online lab and the model that I will talk about, a bunch of us had discussed last almost 1 year ago. So Professor D.K. Sharma, Professor Madhav Desai and Professor Raj Babu and I had just started discussing this idea. We involved a lot of the Vadhwani Lab staff also to brainstorm how we can go about with the logistics. And then the lab courses themselves were offered by Professor Mariam, and so she was offering the digital systems lab course. And then Professor Rajbabu and Professor Sarvanan in our department were offering the microcontrollers lab course. And then all the staff at Vadhwani Lab had helped with the assembly of the kits that we had to send to these students, and all the Vadhwani Lab RAs were very heavily involved in kind of porting our regular lab course content to a format that will be useful for this online mode, and also in helping out students during the lab sessions and so on. So I'll just show you a photograph of the kits that we had to send our students. So these kits were assembled entirely at Vadhwani Lab. So these boards that you see here that we send them. So the one on the left is a FPGA board that we use for digital systems lab. So this board was made at Vadhwani Lab. I don't know if the text is easy to read. Somewhere it says made in Well, IIT Bombay. This is a very old board. Now we are making a newer version of that device. A newer version of that board with a more recent and a more capable device. And the other kit that you see here on the right, this is what we use for our microcontrollers lab. So this board here, the one in green color, was also made at Vadhwani Lab. So here I think it is easier to read. It says developed at Well long ago. This was perhaps in 2012 or something like that. So we sent every student kits like these. that had a few components, breadboard, speaker. There was one experiment where they had to do something with the speaker and so on. And all of the packaging that you see here, putting this in the box with this checklist of what all is present and what all is issued, and somebody signs on it, verifies, right? All of this we did internally. Like Pradeep talked about a vendor, we also did explore options for a vendor. But our problem is the class strength is so large. We have 200 students in a batch. And when these two courses were offered, the microcontrollers lab, two batches had to do it together because one batch had missed it because we thought we'll just postpone the lab to after the pandemic. But then we had to operate it for them, the next batch, and then this course as well. So between these two courses, total we had TAs and students numbering to more than 500. And TAs also were at home, right? They were not here last year. So we had to send everything to everybody. So we had to put together more than 500 of these boards. And the vendors that we were finding were not able to commit to such large numbers. And remember, this was September, October last year. So most companies were still coming out of lockdown and they had problems of their own. So we did not find somebody that was willing to work with us for such large numbers. So we had to do it ourselves. Um, so I'll just talk about how this started. So this had started with a department faculty meeting almost 1 year ago, where we very optimistically said, if needed, we may have to do online lab courses in spring semester. Right? We were foolishly hoping that the pandemic would end before that. But the motivation was that we cannot keep saying that we will do labs in the next semester because like this tomorrow never dies, right? This next semester never comes. I mean, it's easy to just keep saying we'll do it next semester, but then chances are a batch may just graduate without having ever done a lab course by themselves. So we wanted to do this, and we decided to do these two courses because here most of the content was already ready in this format. And I will just show you all the other kind of boards that we have. So here you just see a photograph of different boards that were made at Vadhwani lab over multiple years. And so this particular one you see top left is a first version of that FPGA board. This was in 2009. Then we had this board, which we sent to our students now. One you see here where my cursor is, this is the newer generation FPGA device. So this board presently is being tested. Now it is ready. Now we will make more of them. But when we will actually introduce in the course, we will see maybe next year or after that. And similarly, there are other lab courses. We have a communication systems lab course that also uses a board that has been made at Vadhwani lab. And here you see kind of this semiconductor device experiment. So here is a MOS capacitor experiment, all bar, measuring conductivity of a silicon wafer. So all of these kind of jigs also have been made at well. So this all started way before the pandemic, and we did not do it because we were anticipating that there would be a pandemic and we would have to do online labs. This had started because we have this pool of large number of research assistants in the lab, and they primarily assist with teaching duties, the lab course operation. So they help us as TAs, and then they help with lab maintenance and preparing handout and slides and so on. But we always used to think that we should engage these RAs in more kind of developmental activities. That way, within the lab, we will have a skill set, right, of board design like this and software design and so on. So all of these started out as projects, and some of them we found that okay, if we use them in our own lab courses, it saves us some money. And also we have complete control on the design. So we are not dependent on any company if they discontinue a product, right? It's not like then we suffer because we own the entire design, so we can do things our way. So this was the motivation, and because all of these activities were going on, we could operate these courses. So we had decided to do it with this microcontroller board and the FPGA board because those two we felt are perhaps easiest to operate in this online mode. Analog electronics and so on, I'll talk about towards the end, because again, the oscilloscope that Pradeep showed, getting such large numbers of them and sending it to students, and if something goes wrong, coordinating all the tech support, our batch sizes were so large. Uh, so I was saying our batch size is so large, so operating analog electronics kind of courses was not something that we could have easily done this last semester. So I'll talk about towards the end what we decided to do. Um, so I'll just talk about some of these constraints here. So we had to make a lot of these boards. Like I said, more than 500 had to be sent, and we had to do them during the October to December kind of time frame last year. So initially we decided that maybe we will operate until midsem, we will operate the courses with a simulator tool, just illustrate concepts. And by midsem week, if we can send the students boards to their homes, then after midsem, they can do the labs using the kits. But actually, we managed to finish making the boards December 2020 itself. So before Republic Day, I think all students had the kits with them. So we could start the hands-on components much earlier in the semester. We were trying to get all our RAs back so that we could actually go about this exercise, but that wasn't happening. So we got some project staff and our institute staff in the lab also helped in getting all of this together. And the RAs, we just send them some boards ahead of time in December. So they were able to at least get trained and train some TAs also, the MTech TAs. And more or less, the course management was fine. We did not run into any um, problems where TAs were feeling stuck or they were not able to help students. We had a lot of videos pre-recorded. I will show them in a little bit. But the last point again was important, and this ended up consuming significant amount of time for us. So, uh, and this we problem we used to see before the pandemic also. Many of our students have, they will have either a MacBook or they will have some Windows version which does not support some software that we ask them to install. So before the pandemic, we would just give them access to lab computers and they could just do the experiments on them. But now that option it doesn't exist. So somehow or the other, they have to make it work on their laptop. So to deal with preemptively deal with all the software compatibility problems and so on, we decided to give every student a live USB disk, so a live disk which has a virtual environment installed. So they need not install any software on their laptop. They just plug in the USB disk, connect the board, do the experiment. The software is already present in the virtual environment on the USB disk, and that's it. So that way we were able to avoid all this tech support kind of problems also. I will just show you a walkthrough video that the staff in the lab made. Maybe the audio isn't necessary. This will just show you um, a walkthrough of how we had to go about making the boards. So I hope the playback will be smooth. It's not very long, it's a minute or so. So I'll stop talking for that minute. All of this work was happening during November, October, November timeframe last year. And each kit, before we sent it to the students, we had two staff test it. So one staff who was packaging the kit would test it, put it in the box, and another staff would then open the box, test it, and then pack it back. So that way we try to make it somewhat foolproof. And in the entire semester, out of 500 plus boards that we sent, I think we had to replace some 5 or 6 boards. So for the most part, I think we did not have any technical problems. So coming to how the courses were operated, I'll come to my notes in a little bit. So how the courses were operated was we had there were two courses. They had slightly different models. In the microcontrollers lab course, the one on the right, there was a problem statement that was given to the students one day in advance. They had to think of how they would do it. And during the lab session, a TA would do a viva. So they had to start with a demonstration, and then TA would have a viva, and then there was an in-lab exercise that they had to work on. So we were worried about students copying because these are all based on coding, right? You have to just write C code on the microcontroller. So we were worried students would copy, but we had so many other problems to deal with. We said that we'll just maybe trust them to do it honestly. And anyway, we had the Viva to kind of catch offenders. So that's how that course was operated. In the digital systems lab, the one on the left, the problem set was given half an hour before the lab session started. So again, students did not have too much time to think ahead on the problem. That way, we at least thought we could eliminate copying. And in the lab, we did not have a Viva. Uh, they had to join in on Microsoft Teams channel and actually work on the thing themselves. And the TA would be there to help and kind of solve doubts, or if they get stuck, then help them out. So all those things were there. And at the end of the session, they had to demonstrate. So obviously, the exercises had to be somewhat shorter than what we would do in a regular lab, but that was okay. Again, with this large number of students, we felt this was the easiest way to manage. So one thing we have learned is, and I think Pradeep would agree, is that it may be difficult to do online labs, but it is not impossible. And I think between what physics department has done and what we did, I think we have shown that it is possible. So we should certainly continue doing more of these. Why is it difficult? It is significantly higher workload for everybody. Evaluation is challenging, so you again have to put more work in the evaluation. More importantly, these things are missing, which actually are very valuable in a lab. This interaction and tinkering and in-person debugging. I mean, you can tinker with the kit yourself at home, but then you cannot tinker with it in groups, which is where you actually will learn things faster. So those are not possible. But then we don't have much option right now. One challenge I foresee with this model, however, is that it is more expensive to run as compared to just operating with video courses. So if the institute, I think, sees value in something like this, then the institute should prioritize maybe fundraising for such activities. Instructors or lab in charges should not have to run around finding funds for education. And I think, however, that these are a stopgap measure. We cannot move completely to online labs for this reason. I think this tinkering and working in groups is very important. So we cannot make labs completely online. So they should not become a permanent solution, is my personal opinion. But I do feel that the self-paced labs in this hybrid model are good. Because like Pradeep also said, you cannot do labs in only 3 hours. We have to give person more time to tinker with it, think about it, make mistakes, correct themselves, right? So we need to give more time. So if we can make it modular, I think that is certainly the direction to go. I'll just show you a couple of more things and then I'll stop and maybe we can have small discussion. After we finished these lab courses, we also did workshop through NPTEL. So we sent some of these boards to students from other colleges, not IIT Bombay, in June of this year. So our goal actually in the beginning was to do maybe 80 students in each of those courses through NPTEL. So total of more than 150 students. But then the second wave of the pandemic came and all our plans went into disarray because the other colleges also had shut down and students' exams were postponed and so on. So we could not do a very large version this time. But with NPTEL, we did about 30 plus students. We had 32 students or so. And then we also sent some of these boards to IIT Dharwad. One of our alumnus from our department, who was Professor D.K. Sharma's PhD student, Professor Naveen Padayanti. He's a faculty at IIT Dharwad. So he wanted to also start these labs there. So we sent him some boards to at least start training his TAs. And then IIT Dharwad is helping him manufacture more of these boards so that they can operate the courses. So I'll just show you maybe the websites that we had for this NPTEL workshop. So this is for the microcontroller lab, where we had all the lab material. There were some videos available and handouts. Um, and I can share these links also in the chat after I stop sharing my screen. So we had this, and then we had a page for this digital circuits lab also, where again there were some tutorials, and then they had instructions for how they can install the software. So this was all very self-contained. And this is one-time effort, because the same effort now, all of this, however, came from our online lab course that we run for our own students. But this packaging exercise is more or less done. Now we just need to keep refining it based on feedback. So one final thing I'll show you is maybe some demonstration videos of students performing the experiments at home, and then maybe I'll stop talking for and take maybe some questions. So here is a demonstration that a student has done with this FPGA board. Turn off the audio, where they just have to light up these LEDs in a particular sequence. So I think they flip the switch, and then the LEDs light up in the sequence that we had told them they should light up in. So this was one exercise. This is one of the early exercises, a very simple exercise. This is from the microcontrollers lab, where this is a Viva. So the student is answering a question that the TA has asked and walking the TA through the thought process. And then they also have to demonstrate what they did on the hardware. And then there is some Q&A. So this is how one of these lab experiments would be conducted. And last thing I was saying about this analog lab. So like Pradeep showed that kit, we have large number of students. So we had started making a kit like this. We have not debuted it yet. It is still work in progress. But this board here has a oscilloscope, function generator, multimeter, everything. And this is a power supply board, which is connected to a wall plug adapter like Pradeep mentioned. And this is of course not packaged. The person that designed the board made this video just to illustrate functionality, but you can do all these kind of things. So this is the graphical user interface for that board. And here they are doing some experiments of frequency response of a filter circuit. And this is, I think, MOS capacitor. See. And the board saves it as Excel file and so on. So this is the MOS capacitor. Semiconductor device characterization experiment, and then using that board they are able to then save the data and process it and so on. So I think these kind of kits we will continue to work on them. Again, we started this kit before the pandemic because I just wanted to have that capability also present in the lab, but thankfully because of that it did help us during the pandemic. So let me stop here. Thank you so much for your time, and let me stop and take some questions or have a discussion.
Yeah. Questions for Siddharth? So, Siddharth, I have a question. So, one thing is, what is the cost of this kit that you sent, roughly?
Yeah. So if you just look at the BOM cost, the bill of materials cost, the FPGA board was around 4,000 rupees, and the microcontroller board is around 2,000 rupees. But the reason actually we went for this in-house designed boards is because some of these components we get as donations from the companies.
I see.
So the FPGA ICs Intel had donated for free, and the microcontroller ICs Texas Instruments had donated for free.
I see.
So that helps us keep the costs low. So I don't have the exact numbers on how much we spent on the boards, but it is significantly lower than the BOM cost.
Okay. And just curious about one more thing. Would the students return your kit and then do you recycle it?
Yeah, yeah. So the 500 plus boards that we had shipped in Jan of this year, we got them back in the summer and used some of them for that NPTEL workshop. And right now, the second batch is doing the digital systems lab again. So we have already sent out 200 plus boards.
I see.
The microcontrollers lab will run next semester. So that semester we will send out the microcontroller boards.
I see. Now, one interesting thing I see here, I don't know how the labs are done in your department, but many times in our department, there is one equipment and there's a group of 3 or 4 students. And oftentimes it happens that only 1 or 2 of them will be interested and doing the experiments, and others are just whiling away their times at times. So here, one thing I see is that each one is forced to do something, which is quite interesting because whether they like it or not, they have to do an experiment and show something. So of course, the group experience they are missing because you talk, discuss, and you tinker. But I think there could be some hybrid model where you could, even in the normal semester, if some students wants to take it, on loan, do something at home and submit, we should probably
Yeah.
permit that. That would
Yeah.
be.
So actually, I think 2012, 2013, before I joined as faculty, uh, some model like that was in fact what was being practiced, where the students were given the board in the beginning of the semester, and individually they would work on the exercises, but then there was some project component also,
I see.
and end of the semester they return the board.
Oh wow.
Now we stopped doing it before the pandemic because the class size was so large, but now I think with this momentum we can go back to that model.
Yeah,
Yeah.
that's quite exciting. Yeah. Are there more questions? Yeah, this certainly shows what can be done. I mean, how, in this difficult times, how you can make things work. Very, very interesting experiment. Yeah,
Yeah.
I can imagine there must be a lot of work that has gone in this, making this happen.
Yes, and it's very satisfying. End of the day, when you see students, not all of them may take interest, but the ones who are interested, when they are happy with this, I think the effort is completely worth it.
Yeah. No, and when howsoever the student is, disinterested, when somebody sees something working, when they write a program or when they do a circuit, I think there is a joy, whatever
Yes.
whatever happens. Yeah. So I think it's very exciting experiment. Yeah, we need to think how it can be made affordable. So that is.
Yeah, so we have been trying to tell these companies to donate components, so at least we can subsidize the cost.
Yeah.
So far that has worked, but then for our internal use, that's okay. But if we have to leverage this model and provide it to other colleges also, then that is an important factor that we have to think about.
Yeah. Thanks, Siddharth,
Thank
for.
you. Yeah. So I would just like to say that if anyone is interested in coming to Advani Lab and looking at these things, you are very welcome. So please stop by. It's in third floor of electrical engineering.
I mean, I'll be the first person to come and visit you.
Okay. Perfect. Yeah.
Very
Look
exciting.
forward.
Okay. Okay, thanks. And we'll take a short break for 10 minutes. We'll rejoin at 12:20 for the next session. Thank you.